All right, we're recording. I believe we are live. So, hey, everybody. Thank you very much for joining us this afternoon. My name is David Diarsa, and as always, host of the Seattle Revit User Group. We're happy to have you with us today. We are going to breeze through the introduction and hand it over to the people that you really want to hear about. But I'm very pleased to have you here this afternoon with me. Today's agenda, like I said, I'm going to say a couple of words, get off the podium virtually here as soon as I can, and head it over to Microsol resources. Today's topic, optimizing Rhino and Revit workflows and data. We've touched on this topic before. We've got returning champions from McNeel as well as Microsol helping us understand this topic, which is ever evolving and very exciting in my opinion. So like I said, I'm just going to get through some thank you for our sponsors, Stopcon and Microsol resources, good friends of seaRUG for a long time now. So as always, a thank you. And as always, a thank you to my fellow board members, which help curate and present this content. So thank you very much. A quick reminder to everybody to check us out on seaRUG, more content on YouTube. Our seaRUG channel, more content coming your way here pretty soon on top of these recorded sessions. So if you find something here you want to share, want to have a colleague look at, want to look at again, always can search us out on YouTube, and we've got a lot of great content on there. So like and subscribe and all the usual stuff. See if we can make seaRUG let's make us a BIM influencer. So help us out with that. And with that, like I said, I was going to be brief. I'm going to hand it over to Annalisa of Microsol Resources, and I'm going to enjoy my cup of tea, turn off my camera and my microphone, and I'll talk to you at the end of the session. Thank you so much.
Thanks, David. And again, thank you for having us again at Seattle Revit User Group. We're very excited to be back here and want to thank you everybody for tuning in. So just wanted to introduce you to the rest of our team, but before we do that, just a little background on me. As David had said, I'm the Director of Marketing at Microsol Resources, where I've been working for the past 18 years. Happened to be a trained architect from Manila and then moved to San Francisco, only to realize that I prefer the business and marketing aspect of the business and the industry. So I put together a program for events like this today with my colleagues. I'm a mom to a daughter who's a college sophomore and a son in middle school and a 1-year-old wire fox terrier. So for all of those with dogs these days, I have to say, excuse my dog for barking. Anyway, I'm delighted to be here. So I understand these days to be an effective designer, you need tools to quickly develop your designs and accurately communicate them to all the project stakeholders. And as a result, we part of that goal in mind, we're here to show you how to optimize your Rhino and Revit workflow and data. So just wanted to show the agenda for today's presentation. I'm joined by my colleague, Sofia Jaramillo, and also Joseph Freund, who will be doing today's presentation. Hi, Joseph, and hi, Sofia. We're also glad to have Ehsan and Nejad from McNeel, the developers of Rhino, joining us to answer your questions. This is the agenda for today's presentation. Also, just to let you know, we are recording today's presentation. I believe David will be sharing that recording with you shortly as soon as we're done. And if you have any questions that you want us to cover today, please type them in the questions panel and we will answer your questions at the end of the presentation. So just wanted to share again the best practices and sample workflows that we are sharing between exporting design data between Rhino, Revit, and external files. So Joseph will show you how to explore your models, do further refinement for documentation using Revit, also known as Rhino.Inside.Revit. So this is what we'll cover today. So we have a lot to cover. Before we do that, I just wanted to quickly pass this on to Sofia, who can do a quick introduction to us. Sofia?
Thank you, Annalisa, and thank you for joining us today. My name is Sofia Jaramillo. I'm the Autodesk Account Executive for Florida and the Pacific Northwest area. I'm also a Rhino, V-Ray, and Enscape Specialist at Microsol Resources. Microsol Resources is a partner and reseller of Rhino software. We also provide technical support and training. We help our clients with onboarding of Rhino, training, technical support, as I said, and also access to free webinars like the one that we're having today. In addition to being a McNeel partner, we are a premier Autodesk partner for more than 35 years, and we are also a Bluebeam Platinum partner. We work with the best of design and construction technology solutions and have curated this suite of software applications for our partners. We have partnered with the companies that you see listed here. So if you have any questions about any of the software solutions or training, feel free to reach out to us at info@microsolresources.com. Next, please. In addition to today's presentation, we also offer various educational events focused on design technology, and we offer AIA learning units. And speaking of AIA learning units, if you're interested in getting these for today's presentation, you can email marketing@microsolresources.com with your AIA number, and we will be happy to apply for it on your behalf. Or you can also request your certificate of attendance by sending an email again to marketing@microsolresources.com. Speaking of online events, we have an upcoming one about prefabrication, modular, and offsite construction on Wednesday. This is on October 25th, 3 p.m. Pacific time. And then on October 27th, we will be hosting a Bluebeam office hours. I'm not sure if you heard the news yet, but last month, Bluebeam announced its business transformation with the release of Bluebeam Cloud, a new suite of mobile and browser-based. This is why Bluebeam is moving towards software as a service, SaaS, and moving into a subscription model. So we will be covering all of this information in that webinar. So we are recording today's webinar, as Annalisa said. We will be sharing it with David, and we will also post it on our website under Tech Resources. In case you want to watch it again or you want to share with your colleagues, feel free to go to website Tech Resources, and you will find that webinar and all the other webinars that we have hosted in the past. Today's presentation will be done by Joseph Freund, who is an AC application specialist at Microsoft Resources New York office. He has provided technical support in AutoCAD, Revit, BIM 360, Rhino, V-Ray, and Bluebeam, and has over 7 years of experience working in architecture. Among his software specialties include AutoCAD, Revit, Dynamo, Rhino, and Grasshopper. He received his Master of Architecture from Iowa State University and his Bachelor of Science in Electromechanical Engineer from Loras College. We are also joined by Ehsan from McNeel. He is a registered architect in the state of Oregon and Texas. In addition to being an architect, Ehsan is a digital technologist for architectural firms, where he worked as a BIM and VDC specialist and is currently working as a software developer for Rhinoceros at McNeel. He received his Master of Architecture from Azad University of Mashhad in Iran. So let's start our technical presentation. Joseph, all yours. Thank you.
All right, thank you, Sophia. And thank you, Ehsan, for joining us today. If you have any questions, feel free to dump them into the Q&A panel, and Ehsan will be able to answer them probably much better than I could. But we'll leave some time at the end for any Q&A that kind of comes up based on the presentation. So make sure you make use of that while you have us here. All right, so I'm just going to jump right into it here. A little bit on the finer agenda on the presentation. So I'll do a little background that I've done in past Rhino.Inside.Revit webinars, just kind of introducing what the technology is. And then we're going to dive right into some workflow examples. The main example I'll be covering today is creating a Revit family based on Rhino Geometry. This is something that I've seen come up from some of the Rhino.Inside.Revit workshops that we've conducted in the past, where after the workshop, everybody just wants to start using Rhino as a means of, or Rhino.Inside.Revit rather, as a means of transferring their Rhino models into Revit and having them show up as proper family components, and not necessarily direct shapes or massing models that they needed to import. We'll also cover how to extract information from the Revit model. So if you want all information, well, maybe not all information, but a lot of the information on all of the walls in the model or all of the casework, you'd be able to extract that out. And I'll show you just how to create a quick Grasshopper script to achieve that. As part of that, we'll also cover how to write data to a CSV. So a big part of being able to reach into the Revit model and database and access information is being able to view that information outside of the Revit environment. So being able to write to a CSV, we'll kind of cover a little bit on that. There's some built-in tools within Grasshopper, but you can utilize Python in order to have a little more dynamic functionality there. And then I'll also show how you can deploy that same Grasshopper script within the Grasshopper player in Rhino.Inside.Revit. So it appears within their Revit toolbar as a button that they just need to click and run that script. So it's a great way to deploy any solutions that you have within your firm. And yeah, and then we'll wrap it up with a Q&A. I'll try and leave 10 to 15 minutes at the end for that. All right, so let's just kind of set the stage here. Again, we've got these two big players in the architecture, engineering, and generally design industry here. We've got Revit and Rhinoceros. Each has their own respective strengths here. Revit is very good with documentation. Once you have that data-rich 3D model, you can slice it and dice it in as many ways as your computer can handle. And then we have Rhinoceros, which has a fantastic geometry engine. And so this is something that Revit kind of struggles with. You know, if any line segment is less than 1 millimeter, Revit doesn't want it. So there are certain specialties here that each of these programs can help you tap into. Now, in addition to the core functionality, you have these additional visual programming plugins for each program. For Revit, you've got Dynamo, and for Rhinoceros, there's Grasshopper. And this is a great way to get into programming and automating processes if you're not too familiar with coding straight into C# or Python. So this was definitely my path. I started with Grasshopper, then started with Python within Grasshopper, and then have eventually branched off into using the standalone Python and C# and VB.NET in greater ways. So I think that this is kind of your gateway into learning much more about both of these programs, but also much more about how to build out automations. Now, in addition to those visual scripting plugins, there are also a wealth of additional add-ins and plugins that you can install for each software. But usually the plugins that are developed there are specific to that program. So you've got Ideate and PyRevit, which if we didn't mention already, Ehsan is the father and creator of PyRevit. So if you have any questions in that regard, feel free to dump them into the Q&A. But yeah, these are all specific to the Revit environment. I know that PyRevit is capable of handling Grasshopper definitions too. So my apologies for that sort of miscommunication here. But generally, most of the add-ins and plugins that are developed for these programs are just specific to that host program. So you've got on the Rhinoceros side, you've got Shape Diver and Kangaroo and paneling tools and Elephant. That's another great one. But yeah, because of the way that they're developed for a specific platform, they're each within their own respective program. Now you've got some programs that can kind of tap into both, and I failed to add in Ladybug in here, but which can work with Grasshopper or Dynamo. But then you have other programs like Enscape and V-Ray, which straddle both worlds. They've got plugins for each of these programs, but generally things are pretty much separated. So when it comes to interoperability, this transfer of information back and forth between the Revit model and say the Rhinoceros model weren't very clear, at least until Rhino.Inside.Revit came on the scene. So what Rhino.Inside.Revit did was, before that, they rebuilt, the engineers at McNeel rebuilt Rhinoceros into a DLL, a dynamic link library, and that allowed them to package the entirety of Rhino 7 as a plugin for another program. And in this case, it's a plugin for Revit. So all of the functionality that you find within Rhino 7, including all of the plugins that you can install for that can now be accessed from a single environment, which is Revit, because it will all run within Revit's memory space. So huge kind of expansion of what tools you can tap into while you have just a single program open, which is Revit. And since Revit is oftentimes the end deliverable, or that final program that you need your design into so that you can document and publish those construction documents, it is very helpful to be able to tap into these various tools that all have their respective strengths. All right, and I just want to cover this real briefly. There was a release of a data exchange connector. And this was announced at Autodesk University. This is not too similar to Rhino.Inside.Revit. It allows for the extraction of geometry and properties from the model, but it's part of Autodesk's new way of connecting or creating an interoperable environment for a lot of these design files, so that you can exchange information between Revit models and Rhino models, and they plan to expand this out to many different platforms. So this is, I want this to be on your radar to some degree, but I think a lot of the functionality that you'll see in the presentation today will be limited to the Rhino.Inside.Revit. And especially how granular and specific you can be as to what you're pulling from the Revit model. All right, so before I jump into the demonstrations here, I kind of want to talk about my recommendations for building a Grasshopper script. Once you get this started, I think it's always good to define the workflow. How is it that you already work, or how do you want to work? And in this case, I'll be presenting an example where we're bringing Rhino Geometry into Revit as a native Revit family. So the idea here is that the design portion would be in Rhino, and then you would implement and place within your project through Rhino.Inside.Revit within the Revit model. Now, what I usually start with is that end goal. What is the final thing that you want to accomplish here? In this case, it is to create a new Revit family. This is the Rhino.Inside.Revit component for creating a new Revit family. And really what's great about the Grasshopper environment is that it kind of gives you a roadmap of where you need to go, what you need to provide in order to make this, to create a successful workflow. So for each one of these components, you have a series of inputs that are laid out for you. And so you can kind of start with that end goal and work backwards from those inputs to build out the logic or the workflow of supplying that information to that component so that it can execute successfully. So some things that you need to consider: what is needed from the Revit model in order to make this happen. You know, maybe you need information on categories or materials from the Revit model so that you can properly associate that with the file that you're creating and the geometry. You also may need to know the level in case you need to then place that family instance within your Revit model. You need to associate it with a level in the project. So there are various things that you need to extract from the Revit model in order for this workflow to go through successfully. Now, you also need to consider what is needed from the Rhino or Grasshopper side. This may be, depending on how automated you want to build something out, there may be a specific layering structure that you would need that has certain names for the layers and sublayers. You could even have materials assigned to those layers and pull that information and match it to a layer or a material within Revit, so that you can have this automatic mapping and flow of information from your Rhino file to your Revit model. All right, and then there's also in terms of this transfer of geometry, because Revit is very specific as to what it can receive, because of that 1 millimeter tolerance and various other aspects, you may need to do some cleanup of the geometry to make this transfer from Rhino geometry, which can be very precise and doubly curved surface and things like that, and then rationalize that or simplify it so that it's in a state that Revit is going to accept. So this may involve simplifying geometry or removing some short line segments, or possibly just drafting out in 2D what one of the projections will be like. Now, once we get into the demonstration example here, you'll be able to see everything that has been built out to generate some of these projections, like the left and right, front and back views of a piece of casework. This example is not going to be a general solution, but it is one possible solution that can work in a variety of cases. Before we get into the Q&A here, let me go through those examples. I'll just Alt-Tab over here to the Revit window, and let me just make this full screen here. And so when I start a script here, it's almost always starting with that endpoint, the desired goal. So this was to create a new family instance, which can be found in the toolbar here under the Revit tab. And so this is the new family component. And let me just switch over to the script that has the full beginning to end workflow for transferring Rhino geometry into a Revit family. So we've got a few different areas in here that I've kind of categorized, or I've grouped together and then colorized this. So that component that I started with is right here. So it's near the end of the entire script. But then everything preceding that was slowly built up, kind of top to bottom, based on how complex I want this Revit family to be. So some of the first pieces of information were the geometry from this model, from the Rhino model space. And so that's all fed into this geometry input, and I'm feeding the various geometries for this family into this merge component here, so that it's all being fed into that one component. And then for each of the 3D geometries from this model, you can then define the visibility with this visibility component. This is under the family panel in the Revit tab. So this is where you're able to construct where and when the geometry that is constructed right here will be visible within that family. So you've got your symbolic line work that'll only be visible within a single view. You've got your 3D geometry, which you would want to be visible in the 3D view, but not every view, like a plan view or front, back, left, right. And the reason for this is for the sake of optimization and to tap into the performance benefits of families within the Revit environment. If you have view-specific geometry that can load up, that is not just always that 3D representation, you're going to have a much better time when working with these large Revit projects. Usually once they get to a certain stage in the project, it can become a little unwieldy to handle everything. So we've got all of our 3D geometry we're setting up here. Preceding that is all of the geometry handling, which I'll get into a little bit later here. But then you need to actually reference that geometry, and that's what's being done at the beginning here, which I've created a small Python script here in order to reference all of the design files that I have within a certain folder. So I have a folder in here on the desktop called seaRUG, and that is, and let me just pull that open here. I'll open up my desktop, and then I'll open that seaRUG folder. So I have various 3DM files in here and grasshopper definitions within this folder, and that's where I'm having this Python script look to, and then generate a list of all of the files that are in there. So let me just go ahead and unlock the solver so that it goes and processes at least the start of this script here. So then you can see I've got my Rhino files listed here, and I have that pumped into a value picker, which allows me to then select which one of these files I want to open and have this grasshopper definition read the geometry from. So I've got this Millwork 5 I want to load in here, and I want to read it from the layer and sublayer family, layer family and sublayer 3D. So it's going to pull that open and read all of the geometry that's on that layer. So let me go ahead and enable this geometry here. And while that process is here, I'll just note that this is one of those areas that I mentioned where if you do have a standardized way that you've modeled all of your Rhino geometry, you can place that on layers and sublayers that allow you to automate these processes, so that when you have the grasshopper definition look to a particular place within the Revit model, within the Rhino model, it's going to be able to find all of that information that it needs there, including even what the name of the object is. So you'll see, let's see, down in here where I reference all of those objects listed from the geometry in that 3DM file. I'm able to get the layer, the name of each of those objects, and it's really in this section that I'm splitting up that geometry by its name within the Rhino model. And let me just actually go ahead and open up the Rhino window here so that we can see that geometry. So here we have just our bit of casework here that has been modeled, and so all of that's being referenced in here. If I turn this on, you can see this is the kick plate. Then I've got the panels up front, and then I have the tabletop there. So I've separated, I've named each of those objects accordingly within the Rhino file, and then that's how I'm able to separate them into different geometries that I'm going to introduce to the Revit family. So you'll see how these are all fed into each of these Revit families in here. And let's see, looks like it's not, it hasn't chosen any of the materials that I have referenced from the Revit model, but that's what what this component is doing, because like I mentioned earlier, in order to assign a Revit material to a 3D object, you'll need to query and get a list of all of the materials from your Revit model. So this component here, query materials, will get a list of all materials from your Revit model, and then you would be able to select those materials right from this value picker. So let me just go down the line here. I'll just choose a layer for each of these. I'll choose stainless steel for the tabletop. Let's choose stained wood for the panels. And then I chose copper for that kick plate. So all of that is then being fed into this component family form, because these are going to be geometries within that family. And so I connect the material that I've selected from this value picker to the material input here. That way, when it's added to the family, it's going to have that material. So once we create this family, we'll be able to inspect this from the Revit environment. Now, what we're doing up above there, within the blue section here, is actually creating the 2D representations of this same object. So you'll see, let's see here, I'll just make some of these views visible so that you can see, for example, the left view there. Let me get the front back view to show here as well, so that you can see what that would look like. So all of this 2D geometry is extracted from that 3D geometry, and then it's being pumped into a different component here, which is component family curve, which is just above component family form. So depending on whether you're introducing 2D line work or 3D geometry, this is where you'll use one or the other within here. So we've got all that pumped into that family component family curve component, and then each of them has a different set of visibility values here. So it's because this is a front and back geometry, I have that front back input set to true, and then all of these others are set to false so that it doesn't show within any of those views where it wouldn't have any value. So each of these are separate. This one up top here is the left and right view, so that's why left and right here is shown as true, and then that's going to show in the left and right view of the family once it's created. So let me just go ahead and select all that. I'm going to enable all of that geometry so that it flows on through to the new family component down here. And then for this new family component, what we're doing is giving it a few pieces of information. We're giving it a category to place this family on. So I want this to be on the category casework. And this is the built-in categories picker, which is under the objects panel here. So you can find that pretty easily here. And what's nice is that you can do a quick search from the top of this. So if you want casework or walls, you can select that right from the list. So it's quick and easy. And then let's see here. We'll give that family a name. So I named it seaRUG counter. And then we also need to reference a template file, which is going to be a file that's in the program data folder. It's where all of your family libraries and templates are stored. So it's referencing the generic model RFT from that template directory. And then I've just selected the overwrite input to true so that if I do make changes, it's going to automatically update that. So let me go ahead and enable this component. So it's going to go through, reference that geometry, apply all of those visibility settings that I showed you, and then the various geometries, and then it's going to create that that family file for the Revit model. So let me just go back over here to the Revit environment, and I'm also going to just shut all of the previews off here so that we don't see any of that. And I'm just going to show you here a little bit on how I have defined the curve as to where I'm going to place this component. So I've got a curve that I've just introduced to the grasshopper environment, but it's just an arc right here. And then with that arc, I'm extracting a few planes, which you'll see. Well, I guess it's not showing within the Revit screen. Let me just open up a quick viewport here so that you can see those few planes that have been selected along that arc. So I'm going to place 3 instances of this family along that arc. And then I'm going to feed that into a component here, which is your add component by location component, and that's up in the Revit tab as well under the build panel. And then there are just a few other pieces of information that I need. I need the family type, which is the family that I just created back here with this new component family. So I go ahead and bring the type into there, and then I'll just select level 1 here for the level to place that component. And as you can see, the component is now visible within the Revit environment. Let me go back here and shut off visibility on that curve. And then I'm just going to zoom in here so that we can see that in plan. Let me also switch over to a 3D view so that we can see all of these components in 3D. So we've got our family component created here. Let me just go to a south view so that we can see the front elevation here. Now you'll notice that that these are shown a little bit differently, and that's because I decided to differentiate based on what will display in the coarse, medium, and fine representations here. So right now this is showing the coarse 3D geometry, but since I am viewing this component orthogonally, so I'm viewing that casework front on, it's showing me the 2D line work for that family. So if I went to the realistic, change that to realistic, you can see that that is just showing the symbolic line work there, whereas for each of these, it's just showing a coarse block. Now, if I switch to a medium, you can now see the full 3D representation of that casework here, still just showing that 2D line work within the front elevation here, because that's really the beauty of this, is that depending on what the view is, you can control exactly what is being shown there. Now, if I go back to the 3D view, we can see this in full color here, and we've got our family components right there. So this is a good template, I would say, for converting a piece of 3D geometry from your Rhino environment. And so this is that bit of 3D geometry here. Let me just do a zoom to zoom extents here so that we're kind of rotating a little bit better. All right, it's not really picking up, but so yeah, we've got this 3D geometry in Rhino that's then fed and read into the Grasshopper script here. we do a bunch of geometric cleanup, which is extracting the front and back views, or left and right, which can be done with some of it can work with the make 2D component, but otherwise you may need to take a section with a plane. So this it's showing red. It didn't have a fully successful intersection here, but you can intersect B-reps and planes and get your geometry in that way. So this is this may seem like a lot, but I think once you have a framework set up of getting from A to Z, then making slight tweaks to allow it to adjust along the way can be very helpful. Let me switch over here to one of the other examples, which is a way for you to export parameter values from the Revit model. And this is a little bit more of a simple script. Right down here is where you can get user input, and this is based on some of the functionality within Rhino with Rhino script syntax. You can tap into the user interface and allow for that user input, either a yes or no or a text input. So that's what I'm doing here. I'm getting a string input for the category that that the user would want, and then it allows them to choose where they want to save the file that will have all of the information about all of the elements that are on that category. So string box and save file name, very useful within Python here. And then that information, so the name of the category can then be used to drive the collection of elements from the Revit model. So you would just need to use this category filter, and then this query elements component, all Rhino.Inside.Revit components. And then you can feed that into your element parameter component here, as long as you have a list of parameters for those elements. Most families or elements that are on a particular category will have many similar parameters. So what I'm doing here is just getting a list of all of those parameters so that I can pull all of their parameter values. And then let's see, downstream here, there's just a bit of data reorganization and making sure that I remove any commas from the pieces of text that I'm getting, so that when I write this to a CSV, which is a comma separated values file, it's not going to separate those values into a new column. And then this last piece here, this is what will then write that data to a file. Pretty simple. And yeah, just getting some, I'm supplying the path here based on the input from the user earlier. But really all that it does to write that data to a file is right in here. Pretty simple. You just need to import the import OS, and then you can have all the tools that you need there. So let's just take a look real quick at what this information would be for let's say the casework that we've just added to this file. So I'm going to go ahead and unlock the solver, and you'll see right away once it goes through here that it should have a bit of user input available. All right, here we go. Came up on my other screen. So it asks, what category do you want to collect elements to export parameter values? So I'll just type in casework, and then I'll say okay. And then it's going to ask me, okay, where do you want to save that export file? I'll choose this seaRUG folder, and then I'll say casework export. Save that in here. It's going to go through, collect all of the information. Looks like there was a little hiccup here Oh, I think it's because this portion of the script would get more information if it was a wall. But there was no wall, so it's not going to get your start point and end point. But in the end, you'll have a bunch of information here as text that is all comma separated. That's what you'll need to do right back in, let's see here, right here, where you join everything together with a comma. So it brings all the text into a single line of text, just separated by that comma. So this is the contents of all of that text that is then written to a file. And let's go ahead and check that file within our folder here, casework export. And we'll be able to see our 3 elements that were created there. We've got our family name, seaRUG counter, various other items here like the category, and you've got them all organized across the top with the property values, and then everything listed down below. So we could do this again for walls or what have you. Let's actually, I'm going to go ahead and save this file, and then I'm going to go back to just the Revit environment. And let's say I want to now get all of the information on the walls in this file. Or you know what? Tell you what, I'm going to go and open up one of the basic sample projects here, so that I have a little bit more to work with there. But you'll notice that within the Rhino Inside tab within Revit, it has, to the right of the grasshopper player, you have a bunch of these folders and scripts here. And let me pull that up again. So all of these listed here, they're here because I have specified within the options in Rhino Inside Revit, in the scripts tab, I have specified a couple folders in here that I want Rhino Inside Revit to look, and if it finds any grasshopper definitions, it will then add them as buttons to your toolbar over here. So because I have added these here, and I can remove that here so that we regenerate everything in here. So now all of these are grayed out, but these are the 2 grasshopper definitions that I have in that seaRUG folder. And this is actually that file that I just saved, that I went through that export process with. And again, this is a way that you can deploy within your organization so that you can have the grasshopper experts doing their thing. And then if you want to supply a tool to the rest of the team, you can just have them add that script location, and as long as it's pointing to a central directory, it's a pretty quick and easy way to deploy a set of tools. So let me just run that grasshopper script here. Pull that over. We'll do the same thing on this file, but instead I'm going to get all the information on walls, the category walls. So I'll say OK here, and then let's go ahead and choose the seaRUG again, and I'm going to just overwrite this walls export. Right now it's 3 kilobytes. I'm pretty sure it's going to be a lot more than that, because this file has quite a few extra elements in it. So there we go. It's finished up there, and let me go back to the seaRUG folder. We've got our walls export, which is now 57 KB, so has quite a bit more, and hopefully everything in there is neatly organized and will allow me to see all the walls that are posted in that model. And pretty quick and easy way to get the information about all of the elements of that category from the model. So we've got our categories there, and at the end here, this is where I oh, looks like there was some error there. It was supposed to get the start and end points of each of those walls, but I'll need to troubleshoot that later. But you can get all kinds of information on these walls that are within your project. So you can then create a full export of all of the different categories that you want exported from your Revit model, and then deploy it as tools within the Grasshopper player here. So pretty quick and easy to do that, and I think that just about wraps up the demonstration portion of the presentation today. I can always pull up that other definition that we had going here, and to kind of highlight any areas that you might want some clarity on. Oh, it may have errored out because I already had this file open, but it was able to successfully export the majority of it there. But yeah, just as a recap, kind of started at the endpoint where you want to, what's your end goal with this script, and then work backwards based on what that component needs. So then we supplied all of the geometry and all of the visibility settings for each of these. So that's when you can specify which views you want it to be visible in, and then which graphic displays, whether coarse, medium, or fine, you want it to show up in. And then everything in here is geometric manipulation, just to either clean things up or make sure that everything is accurate to the view that you want it to represent. I've added in a few other areas here where we can do a bend transformation of that geometry. I'll just first disable some of the geometry here, and then I should be able to redo that with just a simple bend around a curve. So you can see how fairly quick that processed. I'll just go back to level 1 within that original file so that we can see. I'll go back to the 3D view here so that you can see how quick and easy it is to then make this change. So I'll just make that change there, unlock the solver, and hopefully this works, but it should be able to then rebuild that family so that it's bent around the curve that's specified there. So you can see, see that a little bit more right there with a slight bend to it around that arc. So depending on exactly what you're trying to accomplish, I think Rhino.Inside.Revit can help connect your workflows from the Rhino environment to the Revit environment. All right. So let's just switch back to the presentation here. And at this time, I'd like to open it up to any questions. I'm not seeing any numbers next to the Q&A. Maybe they were dumped into the chat. But did you see any come through, Ehsan?
Yeah, well, 2 questions from the same person, so not that many, but I assume that everybody's going to bring their questions for this Q&A section, I guess.
Okay, sounds good. Well, while we're waiting for more questions, Ehsan, do you have any recommendations for somebody that's just starting to get into Python and working with Revit and Rhino? Was there a place that you started, either as a resource, or was it just like tinkering, or how did you get going with that?
Yeah, so I guess there are a couple of different things that usually come up when somebody starts learning Python, especially in regards to being able to work with .NET applications like Revit. A couple of things I can use this time to kind of explain a little and clear the confusion. I would highly suggest everybody that wants to learn Python start learning Python from online resources that sort of like, generally teach what Python as a language is. I learned it from the tutorials that are available on the python.org website, which is the official sort of like source for CPython, which is the most popular implementation of Python that is being used out there. So that gives you the ability to learn the Python as the language itself. And the language is fairly simple. I always joke about it that if you used to use a programmable calculator when you were back at school, now in day and age, you can learn Python because it's kind of like a very advanced calculator in your hands. And the language is small and simple. When you actually get inside of Rhino and inside of Revit, what you end up using is a flavor of Python. It's a different implementation of Python that's called Iron Python. And that is an implementation of Python on the .NET framework. What I mean by implementation is that when sort of like the Python language was designed, it was standardized, the committee set the specification for what the language is, like how a print statement should look like. And then the first official implementation of that specification was the CPython, and it still is. There are many other implementations. One of them is Iron Python, that is sort of like a dead project at this point. We were waiting to see, if they are coming up with a new version or not. But all the .NET applications that run Python at this point generally use Iron Python. What that means is that you kind of have to be, it's the same language. It's basically Python 2.7 standard. It's the same language. The name of the libraries might slightly be different because it's an older specification of Python. And then the most complicated part is getting used to making calls to .NET APIs like Rhino Comment and Revit API. If you start sort of like from the Revit side, you might actually get this confused about like what is the syntax of Python versus how am I actually using the Revit API or Rhino API in there. But I feel like if you start on the Python side and sort of like just to get the basics of what the language is, and then add whatever that's is necessary when you get to the Revit API, it would be super helpful. That's actually how I ended up learning Python. I used Python for many years before I even like touched Revit for just general purposes stuff. Python is a great utility programming language. So if you want to imagine the size of it, imagine it a bigger size calculator, like a graph calculator that you might have when you were going to school. It's not a big language. But it's incredibly powerful. I use it to organize files on my drive, to send automatic emails, to like all the other stuff that I might need to do. So that'd be my suggestion. One other thing I wanted to talk about something, but I kind of forgot about it. Anyway, it'll come back to me.
Okay, sounds good. No, thanks for all of that background. I think it's yeah, with Iron Python, that was really where I got going with Python, and it was it did kind of have the training wheels because there were a lot of things that I tapped into in the CPython that I didn't have access to, like NumPy, and I used pandas a lot to just manage large sets of data and data frames. So that's something that if I do need to make use of that, that's where I've turned to hops, and I send that information out to those servers there, so that CPython can process it, send it back to Rhino, and then I have what's needed there.
Yeah. So
and I know that you've hosted some hops with CPython webinars in the past. Is that right?
Well, yeah, it's mostly Andy's project at this point, but we kind of collaborate. He takes care of a lot of compute stuff, and I'm generally fixing and updating the Python component, the Python basically package for hops. That's sort of like you can create your own server in Python and all that. I wanted to add that CPython implementation through a library that's called PythonNet is becoming very popular. Dynamo has support for CPython now. PyRevit has a level of support for CPython, an older version of it. And then I'm actually, one of the main projects that I'm working at McNeel is the new code editor for Rhino that has support for the modern C# and they sort of like a modern CPython inside of Rhino and Grasshopper.
Oh, okay. Perfect.
So
Yeah,
yeah, so
it's,
access to NumPy and all those scientific packages that you want to have are possible very soon.
Thank you. And then Ehsan, thanks for the resources. I've actually been posting them in the chat box too for
I
those that
noticed that.
were,
Thank you.
yeah. And I'm just curious to find out which one is the most recent information for PyRevit. Is that the GitHub site?
So the PyRevit website, what I have is called wiki.pyrevitlabs.io. I'll type it up in the chat.
Okay, thank you.
Actually, I think you have to do it because if I type in
It's not
won't see it.
it's not the GitHub. Sorry, is that what you mean?
That's fine. That's fine also. If you click on that link and go to the GitHub, on the top right, you'll see that wiki.pyrevitlabs.io link.
Oh,
They'll
I
take you
see.
to the documentation for PyRevit. That's where you find all the videos that I've made about sort of like, writing Python scripts inside of Revit environment. There's a great section in that documentation that's called developer docs for anybody that wants to sort of like get into the development with Python on Revit. There's lots of documents, lots of resources about what PyRevit is and how it works and all that, like the internals of PyRevit.
Got it. Okay. I just saw that too and I posted it there.
Thank you.
Okay, sure.
No, I think everything with Rhino.Inside.Revit, PyRevit, I think they're great frameworks for any users out there that are interested in taking the functionality of these host programs, whether it's Rhino or Revit, to customize them a little bit further for their workflows. And if there's something that you want it to do that just seems a little out of reach, it's something that you could read up on the Revit API docs, learn what can be possible with the methods that are available, and then be able to code your own solutions to it.
Yeah, and you mentioned that PyRevit can run Grasshopper definitions too that you have created inside Rhino.Inside.Revit. One of the really important aspects when you sort of like start developing for your company's deployment, how you get these tools into the hand of the people that want to use these tools, but don't necessarily need to know exactly how they work. PyRevit is a really good solution for that because it has this concept of bundles, the tools that you add to your Revit UI. And inside a bundle, you can have a Python script, you can have a C# script, you can have a Dynamo definition, you can have a Grasshopper definition. So different things can be inside of it. And depending on what sort of like file format it's there, it uses a different backend to run that for you. That means that you need to have Dynamo installed or Rhino.Inside.Revit installed for these scripts to actually work. For Python and C#, it already has its own backend, but for the other ones, it kind of needs the whatever that Dynamo environment is and whatever the Grasshopper environment is to work.
Okay, sure. No, that's all great. We've built some internal tools to do some Revit model health checks, and they're all built on Rhino.Inside.Revit and PyRevit. So I thank you for all of your work that you've done to help make that possible, to build the foundation that we can build these tools off of. And yeah, looking to see what interested to see what everybody out there in the design world comes up with themselves as well.
Yeah.
All exciting times. And on that note, I know we're close where we are at 4 o'clock. Just wanted to find out if David had some last minute announcement for us, and just want to thank everybody again for joining us today. We'll have the recording for you, and if you're interested in the continuing education units, just send us an email either at rhino@microsolresources.com.
No,
And
just from me, a big thank you to Microsol and Resources and McNeel. As always, we love having you. Your presentations are always great, very interesting stuff. I'm not gonna pretend that a lot of it doesn't go over my head, but that's all right. That's homework for me. It's all exciting, and I certainly see the power of it. So yeah, with that, really thank you very much for presenting. Thank you very much for everybody for your time this afternoon. Be on the lookout for an announcement for the next meeting. We have one more left this year. And then be on the lookout for announcements for next year's calendar. So I really thank you. I'm glad that you spent a part of your afternoon with me, and it's great seeing familiar faces and having this team present. So again, thank you so much, everybody, and we'll see you on the next one. Thank you.